In this lecture, we want to look at a story problem. And basically, through this lecture, we want to understand that why do we need to learn inverse trigonometric functions. The figure shows, this figure shows a stationary communications satellite positioned at 13,000 miles above the equator. Question: what percent to the nearest turns of the equator can be seen from the satellite? And here the diameter of the Earth is 7,927 miles at the equator. Okay, so how we are going to do this one? First, we need to understand the question. Okay, right here, the figure shows the stationary communication satellite positioned at 13,000 miles above the equator. If the satellite is here, okay, and then let's say this is the equator, so 13,000 miles means from the satellite to the surface of this point. Okay, yeah, that's the meaning for 13,000 miles above the equator. Alright, from A to P we know is 13,000 miles. Now this is the equator. We want to see is that first we need to figure out is that from this point to this point, the length of the arc. Let me say this point is B prime. Okay, B prime. So from B to B prime, this arc, how long is that? And then we want to find out that the ratio of this length arc B prime to the length of the circumference. Okay, because the circumference of the equator is we know, and if we know the length of the arc B prime, we find the ratio in percentage, then we'll find out our answer. Okay, so what percent? This percent means the ratio of the length of the arc B prime to the circumference. Okay, that's what we need to find out. And here we are given the diameter of the Earth is 7,927 miles. And then we immediately know from O center to B, the radius is half of the diameter. 7,927 miles divided by 2 is 3,963.5 miles. So from the length of OB, the radius, or the length of OA, the radius, is 3,963.5 miles. Okay, now here is the way we do it. We know the length of AP, which is this much, and we also know the radius OA is 3963.5. We also know the length of LB. So if we look at the triangle OBP, this one, this is a right triangle. Here is 90 degrees. Okay, that's the thing we want to be clear. Alright, So this is the point, and then if you go further, you cannot see the point. If you go further to this side, then all the points can be seen from the satellite. And this B is the tangent point. Okay, so here is 90 degrees. I can mark here is 90 degrees. That's very important. And so is this place. Then this angle PBO will be a right triangle. And for theta, if here we name the angle is theta, then the radians over this part, the length of PO will be what? Will be 1 leg over hypotenuse. This will be what? Cosine theta. Okay, so cosine theta is 3963.5 over the sum of these two segments, OA, AP. OA is the radians, and AP is the distance from the satellite to the equator. So we have a cosine theta, which is 0.2336487164. If we know the cosine theta, of course, then we can, by the inverse trigonometric function knowledge, we should be able to find out theta. Okay, that's not a problem. So basically, theta we know if we know cosine theta. So let's say now we have found theta already. Then how long is this arc? AB. You know, if we know the AB, then we double the arc AB will be the arc BB prime, because you know A is in the center of this arc. Okay, so how long is this arc? Well, since we know the angle theta and we know the radians, we can figure out the length of arc. So here is the way. The length of arc equals the radians times theta. That's the formula. Okay, so the radians is 3963.5, and the theta, the length of the measure of theta, you choose arc cosine of this one, that will be theta. Okay, so then we can do further is that, okay, after the calculation we then have 5291.144644 miles. Okay, miles, because here they are all in miles. Okay, so you may put miles if you want. Alright, now if we double it, AB, then we'll get BB prime, this arc. And then basically we calculate is that we double this length of the arc 2 times the length of arc AB, and then divided by pi times d. Yeah, pi we know is 3.14 something, and d is what? Is diameter, is diameter. Okay, then we can calculate the ratio, which is approximately 0.425, and which is 42.5%. So this will be the final answer. So what portion of the equator can be found? This is the actual length of the arc, and then that will count 42.5% of the whole circumference of the equator. Okay, so basically two satellites are not enough if you have another one right here. Okay, but 3, one here, one here, one here, and you should be able to find all the part on the equator then can be seen. Okay, all right, please review this lecture. I'll see you next time.